Hi, welcome back. This is Sir RJ, and today we are going to talk about isometric view. So what do we need for today? We need your drawing paper, a T-square, your pencil, your technical pen, an eraser, a ruler, and we need one triangle. Later on, you will know which of the two will you be needing. So let's begin. An isometric view is a pictorial representation of an object drawn in two dimensions. The angles are projected at 30 degrees. So let me just show you first the final output of what we will be doing. So this is our final output. And let me show on the screen our given. Okay, so from this orthographic projection, we will create a 3D object on our drawing paper. I also have here a copy of the given, and we will begin. The first thing you have to do is you have to measure your given, but since the dimensions are already given, we know that the length or the width of the front view is 6 centimeters, 2, 2, and 2. The height is 2 and 2, 4, and then the length is 6 centimeters. So we will start by putting a horizontal line. Next, from the horizontal line, we will create a vertical line, like so. Okay, now, remember the dimensions. I've said 6, 6, and 4. We are actually going to put that here. Remember the multi-view? So we have the front, the top, and the right side view. So if we have an object here in the front view, and then this is the right side view, and if we are going to look that in perspective view, there is actually a line here that connects the front view and the right side view. That line is actually this line, our vertex. So what we will do is we will create or project lines that will form our object. So from your apex going upwards, we need to look for, or we have to measure 4 centimeters. So let's leave a mark there. Now, since we already know the bounds or the topmost line, we will create our slanting lines or the projected 30-degree angle. Now, again, which of the two should we use? A 45 by 45 or a 30 by 60? So I'm guessing you got the answer correct. We need a 30 by 60 triangle. So definitely this one is 30 degrees. This is also 30 degrees. Now since we already know the topmost corner, we can put projected lines there also. Okay. Now remember that this is on the front side, this one is on the right side. We have to know the measurement of this one so that we can place it here. So this is 6 centimeters. We will measure 6 centimeters from our apex. And then the right side is also, now by the way, there are no indicated measurements, but if you can remember from our orthographic lesson, the top view, which has the measurement, is projected down to the right side view. So this length is also the same length of this one. So the total length of this one is 6 centimeters. So we've marked those two spots. We will now create vertical lines for them. Now let's create this side. Like I've said earlier, this side and this side is actually our vertex. This side is this line. This line is this line. Now this line is actually this line. And this one here is this line. Okay? Now we are going to create that line. How should we create it? We know that the height of this one is 2 centimeters. So from our apex, we will measure 2 centimeters. So there we go. Next is we are going to project lines. Another 30-degree line. Like so. And the measurement again is 2 centimeters. So we will measure again 2 centimeters. And then from this line, this point, going upwards, that is also 2 centimeters. And then this side is also 2 centimeters and then also 2 centimeters. So there we go. This actually looks like our front view. Now let's try to do the right side view. We know that the height of this one is 2 centimeters also. So from here to here, this is 2 centimeters. There should be a line going to the right side. So now what you are seeing is a semi-completed right side and a completed front side. When there are intersecting lines, new points are created such as this point, this point, this point, this point, this point, this point. There are lots of points. Now these points created, they need to have a line for them. Okay? I hope you are getting what I mean. Say for example, in this block, if we have a line here and we have a line here and they met at this certain point, definitely there is a line that extends downwards or upwards or whatever. In this case, there is a line downwards. So the same thing applies to our drawing. Let's say this point, there are connecting lines. So we have to create a line for that point. Now let's look at the other side. There is a point here. You will also have to look where the line should go. So for example, this point, we have lots of options where to go by using 30-degree angles. We can go farther away, we can go inside, or we can go across. So in this case, since there is already a line here, and definitely we won't go outside of the object, so we have to put a line across the object. Now, a new intersection was formed. Since there is a new line formed here, let's create a line for that one. So let's just complete other intersecting points. Okay, that's actually it. We have already created, this is our front side, this is our right side, and the top side. Let's try to ink it. Okay, now the question is, Is that our final object? Not yet, because we have to show the hidden lines. In a three-dimensional object, there are lines that can be beneath or below, on the rear of the object, much like this one. If you look at it from the front side, what you will see is an object with a line across because it has two parts. But if you look at it from the back view, you will only see this is the front, this is the back. So at the back view, you will only see a solid space. But it won't erase the fact that there is a line on the front view. So that's why we should put hidden lines to denote that there are solid lines in other parts of our object. And hidden lines are denoted by dashed lines. So where are the hidden lines on our object? Let's try to locate them. Like I've said earlier, points or intersections, intersecting points, they should have lines. So definitely, in this intersection point, there should be a line there. So let's try to ink some hidden lines. And by the way, if you will notice on the back side, the front side is almost, it looks the same as the front. Our front looks like an inverted T. So it is only logical at the back side. It should look also like an inverted T. So there we go. All we have to do now is erase the pencil marks. Okay, so there we go. This is our final object. I hope you learned something from me today. Hope to see you again soon. Goodbye.